name is Victor, and I'm honored to be here as a host for three of my favorite the panelists to talk about the decentralized storage and computing. This is a very interesting topic. So let's start from the panelists introduce themselves. What about, I think people know Jason and Charles very much today. So let's from the teachers.
Yeah, that's go ahead. Hi everyone, my name is Tejas Chopra. I'm a senior engineer at Netflix. And along with that, I'm also an advisor to many blockchain companies and startups. I recently also was awarded the Tech 40 under 40 for my contributions to cloud computing and storage. So I'm very excited here to talk about the potential of decentralized storage and what the future looks like, especially today when we are looking at generative AI, LLMs, and so many other things. So it's an exciting topic.
Thank you. Welcome.
Okay, so I'm Chad Piper. I'm a chief architect of GoChain, and I'm also an associate teaching professor at Rutgers University. And I say congratulations on the award. That's a great too. I'm very interested in decentralized technology, and I think the one thing that's interesting is that what we're not going to talk about is which is out of scope, would be the physical infrastructure in countries that would eliminate the ability for us to have decentralized technology to begin with. I'm referring to internet service providers. In China, there are only 3 internet service providers. How can we be decentralized? Yeah. So that's beyond the scope of this discussion, because we can't solve that, and we're all well aware of the of the legal and policy and infrastructure. I mean, so we'll just put that aside. But I think it's an interesting talk. To be able to sit next to someone. Not only they got an award for their contribution in cloud, but also someone that is a senior engineer at Netflix is all too exciting for me to be talking during that. So we're going to be listening and engaging.
Thank you. My name is Jason G. I'm a data scientist, professor, investor, entrepreneur. Love the title there. So I would like to maybe
father, friend.
Yeah, father. I have one boy.
Let's go around the country and do these things.
Okay, so for the distributed computation, I used to work with Filecoin, and I do the mining business for that. And currently, I'm working on second generation of Filecoin. It's called Billion. We are building a system to do the decentralized distributed machine learning things. Yeah, that's something about my background in decentralized storage and computation.
Great. Thank you, Jason. And right now, let's start from the basic concept. And what is the decentralized computing and storage? This time, that's from Jason.
Okay, so when we talk about decentralized, we're always comparing with centralized computation. Like Google built their data center. Even though they built their data center at a different place, they use the distributed technology to do the things. Decentralized is kind of different from distributed computation. Several things. First, the data center, the servers, the machines are located at different places. And I think the top concept for that is we don't have a central place. We don't have a central place. We don't have a central server or central working node to control everything. In the traditional data center, definitely they have, even though they can make things distributed, but they do have a central, a central place to control everything. But that is the top difference. And also, I think for decentralized computation, it's kind of more scalable, more stable, and also low cost. Yeah, that's my understanding for the decentralized
Yeah.
storage.
And I would just build on top of that to move it forward to say that, hey, in AWS, if I have an EC2 instance, I am in a centralized compute. That's what that is. In Google Cloud, it's called compute. It's like EC2 in AWS. It's just an EC2 instance. It's like you're spinning up a server. The difference is that we want this server to be decentralized. We don't want AWS or Azure or Google Cloud to be able to shut off their off. They turn off. We have a maintenance and something comes up, and all of a sudden Netflix, you're watching something, and all of a sudden, sorry, we're in maintenance mode. You have to watch something later. That's basically it. So the idea of saying decentralized compute would mean that would not be possible. That's the simplest way to think about it.
And I agree with that. I think centralized is when you're putting your data in service providers' hands. Decentralized is when you have the option of owning your own data or choosing where you put the data. Historically, there have been a lot of peer-to-peer networks and peer-to-peer technologies that have been built. So decentralization is leveraging that to store data or to compute on data or to transform data. So that's how it's essentially different than centralized computing paradigms.
It's the perfect definition, by the way. Exactly what you said.
Yeah, great. I totally agree. So I think back to the 20,000, the cloud computing is become to the picture, right? And in the past 20 years, the more computing and you can see the more storage is on the cloud. So right now, when we talk about this decentralized computing and storage, and what's the big difference between the decentralized and the cloud? That's from students.
Sure. So like I said, cloud computing is, you have three major players, AWS, GCP, and like with Azure, and you're using compute and storage that they provide, and your data lives there. So they actually can look at your data. They have the ownership. The ownership may be with you, but they have visibility into your data. Versus when you think about decentralized, you leverage a network of peer-to-peer participants that participate in this decentralization layer. And they each have a chunk of your data, which by itself makes no sense. So there is no visibility into the data itself. Now this, when you think about what blockchain enables or what all this Web3 and all enables, it's this three things, right? Privacy, security, and scalability. All three of them can be solved by decentralization and decentralized clouds, because you can inherently have privacy just because no one party owns the data. Security is embedded when it comes to encryption or other techniques that they use, and scalability, because as more peers participate, the peer-to-peer network grows. So your data can actually have multiple points where it has footprint. A simple example is IPFS. It's called Interplanetary File System. And there's a reason why they call it that. What this means is, let's say you're on planet Earth and you have some file, on your computer. Let's say you decide to move to Mars. Now, others should be able to get that file on Mars. You cannot do that with the internet because you need network, you need internet, you need cloud to be able to share files. But in a peer-to-peer network, even if one entity or one node with data lives in a different planet, it can actually seed the content for all the users in a planet. This is a very far-fetched situation, but you can think about places in the world where there is no internet. You can stand up IPFS nodes and still get data given to all the participants, even without the presence of internet. That is powerful, I believe. And that is what decentralization can enable.
Yeah, that's awesome. So I'm trying to demystify this a little bit. Back in the Napster days, like you said 100% correct, it's peer-to-peer. A lot of people make the mistake of thinking that decentralized storage uses a blockchain. We don't store anything on the blockchain, and in fact, it's peer-to-peer. It's node to node. And in fact, if I want to share something with you, my resume, because I want a job under you, work under you, right? Take a sabbatical from Drexel. I want to do some work with you, because I like what you're saying, and I want to send some stuff. I want to share with you, not Indeed. I'm not going to go to other platforms. I want to just share with you, like I did old Napster days.
Exactly.
I'm going to set up a peer-to-peer connection. The issue with decentralization is, okay, from a storage perspective, no one really cares where I'm storing my stuff, whether it's the IPFS, the Interplanetary File System, or whether it's on the storage network, 20,000 nodes, okay? And 99.9999 availability. What we care about, and this is what I wanted to ask you about with constant centralization and hoping to the questions. All right, we don't care about where it's stored. So I know that it's stored, so I'm going to share something with you. The issue is that I only want to share the information with you, and so only you can access it. And so I will have a contract, whatever that represents, between you and I, peer to peer. And that is going to allow, whether you're on Mars or whether you're here on the US in Boston next to the Beat Sixers, but nevertheless still in Boston, you are going to be able to access that because we'll have a contract with each other. I don't care what chain it's on either, by the way, I can be agnostic. Decentralization says that, and this is not separation of concerns. Decentralization says that I can store it somewhere else. I can share it with you. Now the question then becomes, well, how do I know that I'm sharing with you, and how do you know that I'm sharing with me? You know, how does that happen? Again, beyond the scope here, but using W3C standards. In the Go chain, for example, we're using DID documents. And the DID document represents a defense in depth strategy for being able to layer in a expedited fashion. Someone was saying before, they were concerned before about the performance of the blockchain. And so there have been some, Hyperledger, in the last presentation too with JP Morgan, their quorum does quite well with transactions. So much, they're doing quite well. So in terms of transaction, back to decentralization, all it means is that I want to store something with you. I'm going to store it in some decentralized place so the lights can't go out, and that it will perpetuate, it will be durable, it will be accessible later. Okay. And the bottom line is that we have a contract, and that's where the blockchain comes into play. Because we're going to chain of custody, we're going to put in our contract that you and I can access. That's it. My answer.
Yeah, I totally agree with that. And I would like to add one comment about the economy. So we see AWS, GCP, Google Computation Platform, major from Microsoft. What they did is they got investment. They buy machines and they rent the IDCs and they build the data center. And then they charge. They charge by usage, right? You use AWS, they charge you by your usage. But for decentralized computation, totally different. If you have machines, you can join the decentralized network. You can share your computation power there, and then you get payments when user use your machine there. And on the other hand, even for the data owner, you save your data in the decentralized network, you get a benefit. You got to pay because you save your data there. When other client, other business use your data, they build machine learning model using your data, then you can get paid. So you see the whole economy system totally changed, right? So I think that is my comments. For think about that. A new economy model will help the decentralized storage and the management computation, move forward very fast. Yes.
Great. I also want to ask a follow-up question about this. So when the cloud computing comes to the market, and a lot of analysts mentioned that probably the traditional data center are going to be disappeared. But after the 20 years, it's still there, right? And they're still strong. But I mean, the cloud computing is also strong. And what's your views about the cloud computing and decentralized computing and storage? What's the relationship?
How about this? That a centralized provider cannot provide decentralized services on their own. Can we agree on that?
Yeah.
Can we agree with that? That centralized servers, so AWS, Microsoft, Google cannot provide decentralized servers. It takes the collaboration. I think we can start with that, right?
By definition.
By definition. And whose definition? Non-centralization by Lee, the guy who invented the internet when he was at CERN, who was concerned about the information sharing. He was at CERN. If I were going to be any place in the world and I had to come up with the information sharing scheme, I think that not Netflix, but CERN, even more data. CERN because of the amount of data. We're talking about petabytes of data. We just had a professor at Drexel that is putting in for, sent a message to all the professors, in college, at Drexel, hey, if there's any synergy, let me know. I read it, I was amazed. I said, why not use decentralized storage for the petabytes of data? I got this, no, but so there's a real use case. I'd be curious to hear about Netflix with all the data that they have, but the reliance on CDNs, how does that change the issue? Curious.
I mean, CDNs are sort of distributed. They're not, and sort of decentralized, sort of. Netflix is a very big customer of AWS. We have exabyte scale data, and we store it on AWS. But solutions, the decentralized solutions that you referred to, why is that useful? One, it's because it's much cheaper. I think for the person that's using. So for example, if you're storing a file or a petabyte on AWS, you pay X dollars. You pay like 1% if you use something like storage or IPFS.
You're talking about the AWS calculator.
The AWS S3 storage.
Right. Because there's the AWS calculator where people can put in the cost of what things are going to cost. Now, there's no calculator for decentralization because it doesn't exist. You can't decentralize something that doesn't exist. But go ahead.
That's right. And you're not even taking into account the fact that AWS is like Hotel California. You put in stuff, don't pay a lot, but when you egress something out, you pay through your nose. So that makes it more challenging to ever move content out, and that's vendor lock-in.
More challenging for Netflix, not the consumer, right?
More challenging for any. I mean, anytime you regress something out, you pay money to AWS. So if tomorrow Google comes up with a cheaper storage, let's say for archive content, Netflix, someone watches a show because it's out now. 10 years later, no one cares about that show. We don't want to be paying AWS. We want cheaper storage tiers. If something comes up tomorrow, to take the content out of AWS would mean paying a lot more money to them than to actually save the dollars by going to an archive tier. So that's another problem of centralization. You actually get locked in. And that may be one of the things that can push you towards a decentralized storage or compute layer. But the meta point being, the motivations, like both of them will coexist, just like cloud and on-premise coexist. And there's a strong reason for that. On-premise and cloud coexist because of A, cost reasons, second, privacy and security reasons. Many banks, financial institutes don't trust them.
I'm just asking you to think when you're speaking, to think about both the consumer being the company who is providing services, there's Netflix, and then there's also the people that are paying for Netflix.
Absolutely.
So try to talk in both of those, because decentralization is a decentralized concept. It involved everybody. So that's not talking authoritative perspective. I'm just trying to say for people listening.
Absolutely.
So if you talk to that, I'm really interested to hear from your perspective, especially Netflix, what your thoughts are on that.
I think for both the user and the service provider, at the end of the day, someone pays the money, and then someone is the actual user of the service. So whether it's Netflix, whether it's someone who's watching Netflix, it's always the person that's watching Netflix that is paying for everything. So it always boils down to the actual user that is looking at the data or consuming the data. And I think what happens is when you use hybrid solutions, whether you're using a bank, whether you're watching Netflix, they exist just because cloud or decentralization by itself will not be applicable in all use cases. So coexisting and complementing each other is something we will have to live with. There is no black or white answer to it. It's something that is true in any form of comparison.
And let's give a good example of that. I think that's a really good point. And tell me if I'm wrong, and I could be. Going a lot here. Let's say that the usage statistics of all metadata associated with my experience of Netflix is my data, and I should procure that, and I should be able to store that. And so I'll use decentralized storage to store that in my special space. And if I want, I could share that with Netflix, and maybe there's a discount you want to give me. Maybe there's a discount you want to give me for a service. But in the actual streaming of the content, we'll go ahead and stick with the traditional stuff because we need that SDN, the data network, right? But on the metadata, and that allows us to be Web3 compliant because we know the PII is mine.
Yes.
We know it's mine. Yes. And Netflix is famous for many things, but one of the first things I remember is the big competition, where they had 98%. They wanted to do better than that. And they wanted people to be able to, they gave people the data, and they wanted to be able to process this and get a recommendation that's better than 98%. Can you improve what we're doing? And that was the $1 million prize. And so what I'm saying is all of that data, all of that stuff, that was just central. That was everything you're giving. It'd be great if we could say, let the metadata be owned by me. I can share if you want it. Go ahead and use the traditional stuff, SDNs, to get the stuff serviced wherever that's happening. Does that make sense for a combination? And is there a tipping point?
I think data should be owned by the data creator. That is, ownership of data should always be with the creator. Whether or not many companies adhere to that today, that shouldn't matter because they can probably get to that point later. Ideally, and there are many companies that do that. Netflix in some cases maybe not. I have very limited information on this, but like imagine you're using Google right today, and you are using Google Voice or passing in commands or using Siri. They use something called as federated learning. What that means is generally when you put content in, that data flows or used to flow to centralized servers that have machine learning models trained on that data and give recommendations. But really, instead of shipping the data to a centralized location, what if you could ship the models to the devices? So you can then train the data locally on these devices. This is called federated learning. You know, what this does is it preserves the privacy of data. You only need to ship the models. But there are other challenges with it because someone can sniff the parameters of the models and then they can learn more about the model than the data. So there are other challenges with that. But the future would evolve to a point where all of these training, recommendations, and all of that would be done on your devices.
And that's being done now too. In the great points, by the way, just to kind of get this moving. And by the way, at any point, just push us on or tell me to stop, Jason. I was working with a company we were dealing with onboarding, which is a topic also discussion here. And we don't want to leverage SSO. We don't want to leverage AWS, Amazon, or Facebook or Google. We want to do our, I think, Adrian, you were saying that you want identity. Identity is important and you want the identity to be done. So I want identity to be done on my side. So we want to do it on device. We want no internet. And it turns out that there are companies that are transacting with credit card and they want to make sure that, and put the compliance aside, defense and depth. You want to make sure that it's not saved. The information is not saved at all. It's done on device, not a WASM, which is also a device, but on device, okay? On device, no internet, so that you can't, so that the compute, going back to the compute, decentralized compute, so that the compute can be, that's not decentralized, it's done on device. That's essential. You want it done on the device because you don't want to share it with anybody else. And then you want the data to be encrypted, moved out, and then not so from that perspective, that's a solution also that's being done today, where for credit card transactions, they want to make sure that it's completely disconnected, it's done on device, and therefore the information, even if it comes from decentralized storage, where you move that information into that compute space is secure. And there are companies that want to make sure that when they're moving data, that it is secured.
That's right. Thank you, Jeff. And what about you, Jason?
Yeah, I would like one comments about you mentioned further machine learning things. Google uses some other company use them, but basically further machine learning is a central machine learning.
Yes.
Yeah, because even though they push the computation task to different computation node, but they do have a central node to do the aggregation things. I think just 2 weeks ago, I submitted one paper, research paper to a conference called Blockchain Congress. It's in Spain. So we
accept the paper.
Yeah, we are going to file. We already submitted the paper, and also we have a hidden there. It's decentralized federal machine learning.
Oh, nice.
Yeah. So basically, the idea is federal machine learning can solve the problem like data ownership.
Yes.
And large scale machine learning. But in order to move that to a decentralized computation network, you have to change the algorithm. So yeah, there's some comments and some research work we are working on.
Yeah, I think it's important just to explain that decentralization from a storage perspective is one thing, decentralization from the federated learning, but what you're doing with fast machine learning is another thing. And what they're both sharing is that you're taking data from one point, bringing it somewhere else, and that you need to make sure that where the data is when it's being reviewed, when it's being used, when it's being integrated, instantiated into a model, that is essentially why they're calling it easy to compute, that's where the data is being, where it's placed, you put into memory to do the processing. And so we want to make sure that that is secure from everywhere, and that's the important point.
Yeah, great. I think we talked about the data security, the privacy, a lot of stuff. This is all about the advantage, right, or pros of the decentralized computing storage. And right now, I think we talked the pros enough. Move to the cons, all right. So like the cloud storage, there are a lot of problems, as our three panelists mentioned a lot. But right now, the students, customer using the cloud storage, and the behind of that is there is a reason is because of the face they can meet the business, the critical business transaction, right, and business needs. And what about the decentralized, the computing storage? And let's move to the more details in the technical part. And what's the challenge that's to build up this system? And what do you think about the most challenging part?
I can go first. Yeah, sure. So I think performance is very critical because when you use cloud services, you have SLAs and SLOs that they actually provide and they adhere to, or they pay you if they don't. With decentralized solutions, you will probably, I'm okay with something being slow, but it should be consistently slow, and that I'm okay with. But if something is flaky, it's fast, sometimes slow, sometimes that actually is bad for my customers or for the end user as well. So decentralization still has to solve the problem of having the latency guarantees, SLA, SLO guarantees. And I think over a period of time, as we have more participation, more peers, that problem would be solved. The other thing is also consensus. Even to conclude on a single value, when you have too many participants, you need consensus. That requires a lot of message passing, and that's an overhead in some ways. In terms of like the time taken to come to a consensus, or some of the issues that can happen with consensus algorithms. So I think exploring solutions in cryptography that can overcome some of these consensus problems or message passing could be another avenue for research. One of the things that you mentioned is decentralized federated learning. There has been historically SMPC, secure multi-party computation, that does something like that. But one of the challenges with SMPC is even for basic things, it requires a lot of message passing. And so it becomes practically impossible for good scale applications. And how do we then build systems that can mimic the real world applications in a decentralized manner is a big area of research. The other aspect is when you talk about privacy and security as well, there are several solutions today, which may not necessarily go into the decentralized waters, but like homomorphic encryption is one thing. That is a very, very compelling thing. What that means is you work on encrypted data. In simple words, you have 5 and 4, two integers that you want to add, and they add up to 9. Let's say you encrypted 5, you encrypted 4. Now you gave the addition function the encrypted copies, and it gives you back something, which is again encrypted. When you decrypt it, it's 9, which effectively means that they have computed the addition function on 2 encrypted pieces of data and given you something that makes sense if it were not encrypted. That's very compelling. But that requires a lot of energy today and is very complicated to do. So those are, I think, areas where decentralization has some issues today with research.
Excellent, by the way. Really excellent. Decentralization hasn't done anything. Let's leave it alone, right? Yes. I'm kidding, but it's the protocol itself. And would quantum computing facilitate homomorphic encryption? I'm only saying that you're saying it's hard to scale because of the computational power. And you're saying that in BAS, you know, distributed kind of decentralized compute. It's all about the tasks that are being performed on the data. So I'm listening to this, and just to give you context here, I'm sitting next to somebody from Netflix. So when we talk about, you know, decentralization, you're talking about Netflix does what? Netflix does 99% what they're doing is streaming, right? So when we think about decentralization of streaming, to me, it's hard for me to understand, and I'm playing more devil's advocate, how decentralization will play a role in that. Although we've been hinting at it with some of the way that you can SDN and the way that you would decentralize, right, the content into the software that it networks. You know, I'm curious what other areas really you've been looking at.
I mean, Netflix is not just a streaming company now. It also makes movies. So it's a studio as well. And when you make a movie, there's a lot of content. When you stream a movie, you stream 1% of the content that you created when you made it. I mean, pretty much less than 1% makes into a movie as well. So you have these original camera footages, you have these rendered copies and all of that, encoded copies of data. You need a place to store them. You need a place to perform and transform them. And that's where I think there could be value in the future for leveraging decentralization. Today, the barrier is high for us just because AWS has been our partner and gives us rates that are very compelling. So it's not been the tipping point for us where decentralization is giving us a lot of value right now. But who knows, in the future, when the world gravitates towards cheaper solutions there, we may explore that as well.
Is there a motive? Is there a motive for a company to be decentralized? I mean, in terms of the streaming?
I mean, the motives could be privacy, security, all of those things that we care about for our customers.
Put that metadata aside, so I think we all agree with that. I'm working. That's small. I'm more about the streaming and decentralization. I'm curious about that.
So far, the motives are not very clear. Honestly,
It's not to me.
yeah, it's not very clear on the streaming side of things.
Okay.
So that's the short answer.
That's good.
I think for the decentralized storage and dimension computation, this cycle is really, really complicated. So it's kind of a trade-off. One side is, for the traditional data center, the economy model, the top of different. It just gets some investment, buy machines, build all the things. But for the decentralized storage, you don't have a centralized to manage all the things. So it's very difficult to build the system. And like you said, latency is very slow. And also
For streaming, it might be slow, but not for credentials.
yeah,
Not for things that can be synchronized
mhm.
to a wallet in a mobile app that can have a format that works. But for streaming, it wouldn't work. But it would work for proving that I am who I say I am, right?
Sure.
And even for the photo storage, it's kind of slow. You can see your photos to TCP, Amazon, and really quick. But for the decentralized storage, it's kind of slow. I think that's a trade-off. So I would like to see the economy systems kind of complicated because you have to, some of the system you have to create a token there. You have to do the monthly for the token, you grab the funding and then you increase the revenue. So that is another thing you have to think about. Decentralized storage won't be easy.
So can I just put what you said into perspective? Because I think it's a really good point. Jason is trying to say, well, you have services, and then you have the underlying infrastructure that's also a service. It's a service that you're using to service the consumers. In the case of decentralization, the question you're really asking, it's an excellent question, because basically you're saying, well, all right, if I take this over here, and I'm going to say, we're going to turn it off. I'm going to say, this here is Netflix. You can continue to do what you're doing. And I'm going to take Jason's mic. I'm going to say, okay, this is the metadata that I get as a result of some of your engines. You can go ahead and process that data there, but do me a favor, We're going to use the pipeline to my decentralized storage. We talked today about wallets, linking the wallet. Well, let me link my storage adapter as well. We haven't talked about storage. Sitting there trying, he hasn't got any talk today at all. Well, there's a storage adapter that's there underlying all this. Okay, and the storage adapter is saying, okay, here's my storage adapter, my Netflix for my into my decentralized storage, whether it's IPFS or some other network. Okay, I'm going to give that to you. What's missing is the glue between these two. Which is what this becomes right here. This is the glue. What we need to do is be able to communicate with this and communicate with this in a secure environment. Bayes is saying there's compute space. We'll take the data from here as a data storage. I'm representing that storage, and it's somehow being accessed. And so now it's created from here, it's stored over here, and then we're going to bring it over here to be processed into another model. And then what I do with it, at the end of the day, it gets stored where? This is my seat, I'll sit down. This is my decentralized storage, and all my data is here, and it begins to add up like mail put into a box. When I did my dissertation, I have to be honest with you, I collected a lot of data. I didn't get to analyze 1/10 of it all. In this case, in decentralized, what we have to do is we have to be able to connect the two. The data that I have in my decentralized, it has certain metadata associated with it that allows us to associate it to that. There's an attestation that says that it was derived, the government, where did the data come from? Chain of custody, it came from here. It then went to the compute space here, and then it went to, now it's back to here. Everything is hashed, so everyone can kind of feel like they have their own ecosystem in a sense. But really what we're doing is providing a service. It's just that it's a privacy preserving service. And the problem with today is that it's hard to be privacy preserving when you haven't designed a system to be privacy preserving. Let me say it in English. If Netflix, and I'm not saying they do this, and you can tell us, if Netflix was always saying, in order for me to stream something to you, I have to first find out who you are, and all that information has to be authenticated. Of course, that's not the case because they're authenticated once. You said everyone is authenticated, but the sharing of passwords proves that people that aren't paying sometimes in their family are using it, but nevertheless, they are authenticated, right? But they don't care about that. They are in the business of servicing that authentication for the selective choice to make, and all they care about is that the streaming is happening. The data underneath it, when I chose to watch it, how many times I stopped it, how many times I chose not to watch it and watched it again. Anything I may have said, all that stuff belongs to me, should belong to me, if it does, and it should be stored in decentralized storage. Just not where they are. That's what it really means. But that's basically, so how do you put that together? Well, you can take it. And people are doing that now with DSARs, right? You can go to Facebook, you can go to Google, you can ask for your data back. Okay, they'll give it to you, but what are you going to do with it? It's a block. What are you going to do with it? It becomes a zip file that you download. What are you going to do with it? If you want something to do with it, all right, well, I still want to store it in December. I need to store it in MySpace. Okay, not MySpace, but a space that I might own.
Great. So we hear a lot of the challenge here for the system. And my second question for this one is how we achieve that. We know the big cloud computing companies, they have thousands of the engineers. I guess these the most talented people to achieve the problem. And also beyond that, before the cloud computing into the market, there are 30 years in the academic research for the distributed system. And what about now? So for the decentralized, the computing and the storage, how we achieve those challenges? Let's start from Jason.
Yeah, definitely. for every technology, it takes a while to put that into the applications, right? Currently, what I saw there is one data engineers, system architect. We are still working on how to improve the system, even though we already have IPFS, that's the decentralized file storage protocol, and I see some research work to how to try to improve that. And also on the other hand, I see the companies, especially the blockchain company like Filecoin, they release the token, and the token Very good. I think, I purchased that at something like $60, and it's go up to 240, and now it's $5, something like that. So you see, we see the opportunity in this industry. People do make money, even though the system is not used in many cases, but people who working on the system, they make money. So this is something I think, in the future, I would like to see more blockchain projects, they're working on the decentralized storage and definitely if you work on this story, you're talking really valuable. That's another thing I would like to see. If we have the funding, we can do anything. The other part is we see the current decentralized storage is kind of slow. The latency problem there, but we do find some special use case for that. Like if you have some data, you have some files, you do use them frequently. You just want to save the files somewhere, make an archive. Definitely, comparing with Amazon S3, decentralized storage is much cheaper. So you can see the data there. And also, if you want to see, okay, I have a lot of data there. I already saved them in cloud. I use GCP, AWS, or whatever. But I need secondary storage.
Secondary storage.
Yeah,
Secondary storage. Yeah.
Decentralized storage is a good option for you. So that is what I say, in the industry, what we are doing to push the technology going forward.
And providers like storage, I'm not selling it, I'm just saying this is what they're doing. They make it easier too. So you can have an S3 gateway, and then you just do the same thing that you're doing, just now it's going to be decentralized. The issue is really about, again, the metadata that we want to associate with the data that's stored to bring it into some other ecosystem. What I'm trying to say is that if I'm doing some application X and I'm storing my data in decentralized storage, I have to be able to authenticate. Well, let's assume we're authenticating. You still have to authenticate the veracity of the data itself, machine to machine. If you go to Bose or any of these companies and you want to buy something, some companies are using ID.me, ID.me is the company. Not condoning, again, just saying Bose.com does this. And so if you can prove, at least within the ID.me ecosystem, that you are a first responder, you can get like a discount on this. That's just an example of the real use case here. The use case being, at least with consumers, saying, I have my data, it's in a format that is trustable, decentralized, but because I am my own entity, we have to use W3C self-sovereign identity, protocols so that we can machine to machine verify the veracity of data, and not just that, but that the credential itself isn't just that I hold a credential, but that the issuer themselves are real. That I can go to MIT, I went to Illinois, but if I wanted to create an MIT record, I could do something with it, right? I think I can create it, but it has to be real, and so the provider has to also stamp it, and they have to say that I'm the subject of that. That's how decentralization. Once you store something out of your ecosystem, you put it together. Like I think Solon was mentioning before, ingredients in the previous panel, and that's one of the ingredients is being able to match that. But in order to do that, there have to be permissions on that, right? Permissions have to be on that. So that's my question.
To answer your question specifically, yes, there has been a lot of research that has gone into the way cloud computing is today. But not all of it is different than what decentralized computer storage will require. Because decentralization will still rely on distributed systems, which is what cloud computing uses. We have to build on top of that research. And there has been a lot of research done on information theoretic security as well, for example, ITS, which effectively means that even when quantum computing comes into play, your existing encryptions may or may not break.
Quantum resistance, right?
They'll be quantum resistant. It is quantum resistant, right? Yes, secure. So I think those are new avenues of research that will help decentralization. But the work that has been done for cloud computing is not a throwaway. In fact, we will use that to build systems better.
It was a building block. It was a
Yes,
building block.
it's like, yeah.
Great, thank you. As of right now, we can change our direction to the application. And I know Jason mentioned you work with Falcon before, right? So I assume you know the Falcon technologies and all the stuff. And
So for those who do not, Filecoin is a blockchain built on top of IPFS, which is peer-to-peer. As you said, you have to peer-to-peer. And it like you said, it rewards people for using their machines like SETI did back in the day,
Yes.
for storage.
yeah, thank you, Chad. So Jason, let's start from you and talk about what is as you Chad has already explained what is Falcon and what do you think about the Falcon and and what is the current stage of this technology?
Okay, so I was working on the Falcon mining business in last several years. I believe I'm the first group of people who jumped into the business. The business is like you purchase some machine servers and put them into IDC. You install Filecoin software there, and then you can join the Filecoin network, and then you have to buy some token.
Your staker.
Yeah, you have a stake in your token. It's kind of but the good thing is when you finish all this part, automatically every day they will award you the token. It's like you put some investment and you buy the machines and they use your data center and then you get the token. Okay. So that's pretty good. I think 2 years ago it's really good. The token is like when I purchased that, it's something like $60, and just in a couple of months it's go up to $240. And after several years now it's only $5. Okay, so what I would like to see is this, this type of business is kind of risky because the technology is brand new, especially in a brand new technology. We are working on that. That's kind of risky, and also behind that is a token. Okay, so you have to deal with the marketing value for the token. So this is my working experience for this system. Even though some people lost money in the token market, but the Filecoin, the decentralized storage, I believe that is one of the most successful decentralized system in the whole world. Because there are so many investors, they put $1 million.
Well, they got $200 million in their IPO, in their ICO, it's a $200 million.
Okay,
They had a lot to do with it. But look, I'm the opposite of Jason, complete opposite. I'm completely opposite. I have no Filecoin at all. No, okay. And I'm interested in leveraging decentralized storage to store stuff there. And the question is, well, how do I do that? And the answer is, I need a permission layer. I need a permission layer. I need the ability to allow users to choose who can share and what access one thing. That's not something IPFS has built right now. They have a hash. And so what we were doing early on is we were using data. We were using not MongoDB. We were using BigChainDB, and they're the team that started Ocean Protocol, which is one of the original marketplace for AI, which is deep in Jason's heart as an AI PhD. And so I was interested in decentralized storage, and I was interested in finding, well, how can I facilitate getting the data and using it for some system, use APIs, and then put the data back where it belongs. In other words, how do I create this decentralized identity management system? And the only way to do it that I thought, because with IPFS, we like the idea of the hash, and we use big chain. And what we did was we were changing the ownership of the person who could own the asset. And so big chain allowed you to do that. And so I could take something like a card, put a VIN in there, and then I could take it, and then I could give you the ownership of that. And with big chain, I could do that. See, on a blockchain, you can't go in and say, now you can have access to it. Like if it's a private, it's public, everyone does. If it's private, and only one key does. And so, and it's multi-chain, okay, multi-party. No. I just wanted a simple space where I could take decentralized, I could take assets that I have and store it in centralized storage. So on Filecoin, you can do that, but the permission layer has to be done at a different thing. And with storage, which is now called DCS, or Distributed Cloud Storage, STORJ, maybe they were the one that had 200. I think it was 250 actually for Filecoin. Yeah. 250, but I think for storage was 200. They had a lot of money to do stuff. Now they say they have 20,000, 30,000 network. Not 3 or 10 boxes that can do all the mining with the investors that are staking, but literally people like in the SETI. And so in that to answer your question from that perspective, I'm able to leverage at least the permission layer of caveats and macaroons that they're using that Google created. And that allows us to build APIs on what I'm calling the privacy layer. See, I think that moving forward, the decentralized cloud storage is nothing different than cloud storage, except that it's decentralized. But right now, there's a lot of granularity and a lot of confusion because at the end of the day, how much is it going to cost? And so when I did this for this professor, when you had to have 4 petabytes, the issue was that with federal funding, if you get federal funding on yourself, your data has to be accessible publicly. And so then they made some kind of contract with storage or whatever for them to allow the public egress, right? To get it out to use. So the issue for me is the absence of APIs in some of the providers, because there are others too. SIA is another one from MIT, actually. I should mention it here. The SIA, which is a wonderful project too that we've been working on.
To come to the applications where we see decentralized storage and compute, right now, generative AI is taking off after ChatGPT. Right? It has had its moment with ChatGPT. Many companies are looking at AI and specifically AI for their data. Because when you use OpenAI or whatever, you put the data, you give the data practically to OpenAI. So now you have to think, if you have your own data and if you have to train models on your data, how do you do that? What avenues do you have to do that? And there you can see that if the data is humongous, then you can leverage decentralized storage, decentralized compute. But the privacy layer or the API layer that you're talking about is still missing. Yes. So you want to be able to have these LLMs, large language model training, done on the data using decentralized compute, just because it can parallelize that and it can also give you results faster, potentially, than centralized pieces. So that's where I think the next level of applications can evolve, like the intersection of AI with cloud in some ways, or decentralized cloud in some ways.
Interesting.
Yes.
Right.
So in order to make that working, the decentralized machine learning things working, it's not only about the stories. So
it's not.
It's about
What's the schema of the data?
computation task, how you can distribute that to different working node. And also, because it's decentralized, you don't have a centralized place to collect all the parameters, train all the things. It's very complicated. But what I saw there is the good side for machine learning in a decentralized network is it's low cost. Currently, if you train GPT-3, it costs, I think, something like $200 million for just training one model. It uses 3,200 nodes. For each node, you have to have CPU, GPU, and TPU. So it's really expensive. Only Google, Facebook, Amazon, Microsoft, they can do that. But for the small companies, if you want to train your own model, decentralized, machine learning definitely is one option. Because when you work with the network, when you use the computation power there, you will not pay by yourself. Okay, basically you buy the token, you pay the token. The token is token economy, right? When people use the token in much more cases, the price for the token will increase. That means originally you buy some token, you train some model there, but maybe after a couple of months, because the price increase, the gain, your income from the token, much more than what you got from the machine learning. That's something will happen there. So let's see. Okay, I believe currently I saw some small companies that are trying to do that. Yeah, some opportunities there.
So one thing I'd like to add is this, right? I'm a big advocate of carbon footprint, everyone's carbon footprint. And the rule of thumb is if something is more expensive, it has a higher impact on the environment. So now if you think about cloud computing and you compare it to decentralized cloud, the fact that decentralized cloud can make things cheaper also means that it is much better for the environment. When you look at AI, what it takes to train AI models, it is a lot of energy. And it would be significantly reduced if AI were trained on decentralized layer. I'm not saying storage compute, I'm just saying decentralized layer because it's compute, storage, and encryption, and all of those other things. So I think that's another point that we should look at collectively, that as the era, we are in a very interesting time where we have AI, we have cloud, we have so many other things, We should reduce our impact to the environment and be mindful of that as well. So that's another metaphor.
It's an excellent point. When we talk about the consensus in teaching, I was teaching an undergraduate course, like 400 students at Drexel, like 3 professors. And we had this one talk about Bitcoin. And I did this, this thing about consensus and Bitcoin uses proof of work, like you're saying, it's a huge. And then you have proof of stake, where you have these validators that are allowed to make decisions, but they have all the stake. And the question was, if you're wasting enough electricity for the next 10 countries below us for like a year of electricity, is it really worth the waste of energy? And apparently, some security researchers, it might be. It might be, because in a trustless environment, that's what security costs. That's a big cost. I absolutely play devil's advocate, and I completely agree with you on this. Obviously, in that case, yes, it hurts that they're wasting CPU space to do little puzzles for their proof of work. It's quite asinine if you want to be honest about it. But security people are saying it's not asinine. They're saying, wait a second, that's the cost of security in a trustless environment. So but decentralization does provide, at least we would agree, right? At least an attempt, because but then the consensus algorithm aside, at least there's work on potential sovereignty.
Great point. So right now let's open to the floor to yeah. All right, so the biggest part of decentralized is the nodes, right? So you can't be decentralized if there's not enough places where this is running independently. All right, so many years ago, I mean like 13 years ago, the company Lassie acquired Voila, which used to do something similar to what Filecoin does, before crypto was around. And they used to, you would just give them a folder in your computer or a hard drive, and you'd be storing other people's stuff. And it was pretty seamless. Last time I looked at Filecoin, it's been a while.
I have to buy hardware and specialize to do this and that, which probably goes to what you were saying, that I want a certain level of expectations, right? I don't want the fluctuations, but that means that there's less nodes. And the other one is all over the place, but there's more nodes, right? And so I wonder, there has to be a way here to kind of, everybody has iPads just laying around in their house that could be compute devices, right? And even Apple's probably leverage that.
Oh, wait a second, the iPad just turned off. So where's my data?
Well, compute.
Right, yeah. Oh, computer compute.
Right, and so the other aspect of this that you were saying about availability, right? Is like to be able to do something in parallel when your data is distributed, then that means you need redundancy. And if there's a lot of redundancy, then you can probably do great parallel stuff. But I'm just curious where how do we get to Ethereum's, if we look at how many nodes there actually are, how many are actually running like on Amazon, Azure, and Google, right? Like how much is the network really decentralized? How do we get there?
I mean, ideally, in an ideal world, the North Star is that the lowest possible device should also act like a node. That's the North Star for decentralization. Anyone and everyone can be a node. And that's not true. Yes, IoT devices as well. So you should be able to have a Raspberry Pi with some storage attached to it, and that should act as a node as well. You wouldn't want a world where you're putting in a lot of money to buy these expensive machines to act as nodes. That goes against the principle and the idea of decentralization. Of course, we are not there.
I think it happens in the beginning, though. I think it happens. I'm going to say it real quiet. I think it happens in the beginning of these things that they need a consensus to begin with. So I think they got to bring the people in that are willing to invest. I think you said it, Jason. You was
Traffic. Yeah.
I'm just saying he was okay, but you had to start somewhere.
Actually, I cannot agree with you. I don't think the small machines will contribute too much value for the decentralized computation. Just like okay, when we
distinction between storage and computation. Okay?
when we do the BTC mining, okay, you put $5,000, you buy one machine at your home, and maybe after 2 years, 12 months, you get your money back, and then you can earn money there. But what we did totally, we built the whole, we buy the container. Okay, we hire the profession to build the container.
You talking about the containers that were in LA, right? The big ones that are stuck there in LA, right? During the pandemic.
And we put many machines inside. We use oil as the cooling system. The cooling system has been used by NASA. So you see, it's just like you can do something at your home, and also you can, do that in a professional way. Okay, I believe the future for decentralized storage is you have to use data center IDCs. Even though we are happy to, some, individual investors, you put small money, buy a machine there, or you can use something you don't use. But that's not the future for decentralized storage. For the future for the decentralized storage, definitely, I think the data center and also the professionals in the industry leaders, they have to be involved in this domain, even though they may not like that, like Amazon, Google, Microsoft. They will continue working on the centralized storage, but in the future, I believe some other companies, they will jump into this industry. They will go decentralized storage, because if they do centralized, they cannot compete with Amazon, right? So they have to, if they want to do this business, they may put their money into the decentralized storage. So I'm sorry, so
I think one thing is the money that you make by putting a node for computer storage. And the other thing is the type of apps you enable by doing that. I think you will of course make nothing if you're a small node, you know, but you still are a participant. And I think that is what the applications care about. You are a participant. Of course, there will be some companies that will have lots of machines, that will have lots of storage, that will make lots of money in that. But you too are a participant. And that is, I think, how it will evolve. You may not make money at all. That's a caveat. That's making money separate than enabling decentralized applications.
Yeah, no, I think the money part.
It makes no sense to have a small node. Of course, the Raspberry Pi would not do anything.
The quality of service is an issue, right?
Yes.
And the quality of service is something that has to be, the quality of service. I just want to say the quality of service is what you're talking, you're kind of hinting at here is quality of service. And there are recommendations, there are recommended configurations. I remember SETI, I forget what it was, to search for, you know, extraterrestrial,
Yes.
what's with the I at the end, I forget.
Intelligent.
Intelligence, thank you. And I remember as a screensaver, that made a lot of sense, right? Like I'm not using my computer, so use the processor, CPU utilization. Compute is all about utilization. And so, you know, from a utilization perspective, okay, we get that. But quality of service and decentralization, because when you remove a body that's responsible, let me make it really easy, I think. Philadelphia recently, besides being beat by Boston, if you follow the sports entertainment, you have quarterbacks that want to be able to get paid now. You want to get their money back, as it's called, and they should for the dangerous sport that they're in. I think we all saw what happened to Lamar. I think it was when so we all kind of became enthralled. At least I was with football, and so now you have a bunch of discussions about, well, they have agents, and now you're trying to do something, and that seems similar to what we're dealing with here. In the sense of what blockchain is in today's world, because you have middle persons that are trying to be removed. Let me be clear. There are firms that are billion dollar firms that take care of the town. They get the contracts. They don't maybe want someone like Lamar Jackson trying to get their own contract when you have a Philadelphia quarterback, Hurts, who has someone that is represented. And apparently did very, very well, which is great. And so then how do you represent yourself as your own entity in decentralization? And so, yes, people are being paid. And for SETI, there wasn't, it was free. But for Filecoin, and Jason's right, for compute and storage, you know, especially for compute. I mean, if you're offline, it's not very useful to me, right? And so if you think about it from a perspective of singletons, it's hard to think that that's going to be valuable. It's the CPU utilizations that are getting most of the return on investment when the ROI is represented by proof of work puzzles that are being spent, at least in proof of work. But in proof of stake algorithms, it's different. You don't get this number, which is not a reward that way. I mean, there's a different type of incentivization. And so the economy and token economics is different than the decentralization itself. What I'm saying is that the removal of the governance, that business continuity and disaster recovery is an issue for cloud providers because they understand the technologies that they are in charge of, that they control. As soon as something becomes decentralized, it's difficult to figure out who is in control of a certain technology, of a certain, infrastructure. When you talk about cloud, what cloud are you on? AWS or are you on Google? When you talk about decentralization, it's like, what is that? And that's not to say that that should concern people. It's to say that the absence, or at least of that governance structure and that ambiguity, seems frightening to people.
Great. I think this is a very interesting topic, and I believe we have a lot of questions and we want to keep discussion, but since the time is right now, so let's end here. Let's give a round of applause to the